Today we're going to do a crash course on solving exponential functions. Right, solving exponential functions, we readily need to use some of the laws in the chapter of indices. Right, so it'd be good that if you can revise all these laws of indices, right, before we actually look at all these exponential functions. So what are the types of questions that you may encounter in the exam? Right, so I categorize all these questions according to different grades. So grade 1 means the kind of very basic one, you don't really need a lot of workings. Grade 2 will be slightly harder. Grade 3 will be the one that involved more steps, right? Maybe have to use substitution methods, things like that. Okay, so let's look at grade 1. Right, so if you look at these questions here, it's considered grade 1 because you just need to express all the number as base 2, and then you just apply one or two rules of the indices and you can solve it. Right, similarly for grade 2, right, for grade 2 then it's harder than grade 1. Why? Because you can't just, you have to use, it's not just as simple as expressing, you know, all the terms as base 2. You have to apply some factorization here. Then if you come to grade 3, the sort of questions, then definitely you have to use the substitution method. So the workings will be longer than the first two questions. And of course, you may also encounter such questions where you can't use substitution method, you cannot express them at base 2. Then you have to bring natural log or common log to both sides. Right, so grade 2, this questions is similar to what I've mentioned earlier on, except that it's called grade 2 because if you compare the power, it's slightly more complicated than the earlier ones that I mentioned. Then of course there are some other questions that you're given the exponential equations and you're asked to evaluate certain values. Also, this sort of questions you're supposed to simplify. So basically, this is not an exhaustive types of questions, but it's basically you will get an idea of what kind of questions that you may encounter in the exam. Right, so let's solve this question. So like what I've mentioned earlier, we just express all the number as base 2. So you can write you can write 4 as 2 to the power of 2, and 16 is 2 to the power of 4. Okay, so this one here we will have to apply. If you were to recall this rule that you have learned in the chapter in the indices chapter, right? This is the radical form. So if you were to convert it to index form, this will be a to the power m over, n over m, n over n. It's actually quite easy to remember. Okay, if you look at the letter m, it's actually outside your radical sign, right? So that's outside means you just put it at the denominator. And then if your power n is actually inside the radical sign, so you just put it on top, the numerator. All right, so in this case here, 2 means 2 to the power 1, right? So if you're going to apply what we have I've just mentioned, this will give you 2 to the power of 1 over 3. Okay? Right. So like what I've mentioned earlier, so exponential functions is very closely related to the rules of indices that you have learned. Right, so here we're going to apply this rule here, where you have the same base, and if it's multiplications in the middle, you just add power. Okay, so we will get 2 to the power of 2 plus x, and on the right hand side will be 2 to the power of 4 plus 1/3. Okay, so since we have the same base on both sides, then of course the power would be the same. 4 plus 1/3 is 4 and 1/3. So x will be 4 and 1/3, take away 2, right? And that gives you 7/3, which is 2 and 1/3. Okay, so this is relatively easy. All right, so now let's look at questions, these questions. Okay, so which one, all right, let me write down the three terms first. Okay, right, so which terms do you think you can try to develop further? So if you were to look at 2 to the power x, definitely it's just 2 to the power x. You can't really do much to it, right? But how about this one here? I'm sure this one you can do something to it, right? So that's the reason why earlier on I said that you should try to revise all the rules of the indices. Okay, one of them will be this one here. If you a to the power n plus n, you can write it as this, right? So this will give you 2 to the power x times 2 to the power -3. Okay, I understand that you also learned about this. A to the power m minus n will gives you a to the power m divided by a to the power n. All right. I do not want to use the division. I do not want to use this rule. Why? Because then you will end up 2 to the power x minus 2 to the power x divided by 2 to the power of -3. And I have to change the divisions to this symbol. Right. So it becomes kind of more complicated. So even though if you have 2 to the power x minus 3 by right, we will write it as this, right? A to the power m divided by a to the power n. I think in order to avoid having more complicated steps to deal with, right? So we will write it as 2 to the power of x times 2 to the power of -3. Okay. I'm going to erase all this. But of course, in some other situation, then you have to look at the situation. Sometimes you write it in this format, sometimes you write it in this format. Okay, so you just practice a little bit more questions, a few more questions, then you'll know when you need to use this, when you need to use that. All right, so if you look at this question here, yeah, we have to do some kind of if you want, you can use substitution, or otherwise you can use factorization. Why factorization? Because you can see that that's a common factor there. 2 to the power x, that will be a common factor, where you can just factorize it out. All right, and then this you can just simply use a calculator to work it out. Right, you'll get 7/8. Okay, so 2 to the power x will be equals to 28 square root 2 divided by 7/8. So you change the division sign to times, will be times 8/7. Right, and then if you simplify further, that will gives you 32 square root 2. Okay, if you don't quite get why you get 32 square root 2, let me show you. So you write 28 square root 2 as a fraction, will be 28 square root 2 over 1. So if you were to multiply the numerator, multiply the denominator, this is what you get, right? Then 28 can divide by 7 to gives you 4. Then 4 times 8 will be 32 square root 2. Okay? Right, so how do we continue here? So basically this will look like what we have done in the grade 1 questions, right? The earlier questions. All right. So we can just express 32 square root 2 as base 2. Which I'm going to continue here. So 2 to the power x is equals to 32 square root 2. So 2 to the power of x. So 32 is 2 to the power of 5. Okay, you can just use a calculator to help you. If you're not too sure it's 2 to the power how many. You can just try 2 to the power 1, to the power of 2, to the power of 3, to the power of 4, to the power of 5. That will give you 32. And square root 2 is 2 to the power half. So we will have 2 to the power x equals 2. So this one you can just apply this rule here. Okay, a just add the power, which will gives you 5.5. So therefore x will be 5.5. Okay, right. So if you are not too comfortable about factorizing to the power of x, you can actually use substitution. Let me show you how you can use substitution method. So you just let 2 to the power x equals to a. Alright, so you will have a minus a times 2 to the power of negative 3. And 2 to the power of negative 3 is 1 over, okay, let me write it here for you. 2 to the power of negative 3 is 1 over 2 to the power of 3. That is 1 over 8. So you have a minus 1 over 8a. So a meaning 1a. So 1a minus 1 over 8a will give you 7 over 8a. Okay, then you go on to find the values of a, which will be 32 square root 2. Right, and then you substitute your a back to be 2 to the power of x. Okay, so this is using substitution method. If you're not too comfortable about factorizing to the power of x from here, from this step. Okay, so now let's look at a grade 3 questions. All right, this one definitely you have to use a substitution method. Okay, definitely you have to. But before we use substitution method, let's break this guy first. As in you separate it into two bases. All right, recall this. All right, so we separate it into 5 to the power of 2x times 5 to the power 1. Then minus 26. Okay, this bracket here, some of you, if you're a bit too confused about the bracket, you just change it to a multiplication sign. Okay, and this one here, you can break it up further into 5 to the power x times another 5 to the power x, right? X plus x gives you 2x. All right, so usually when we do substitution, we will substitute the unknowns, the one with the variable. So right here, obviously, it's 5 to the power x. So we're going to substitute 5 to the power x. You can let it be any letter you want, A, B, C, D, whatever. So I'm going to let it be the letter A. Okay, so we can substitute inside there. Into the above equation, you have A times 5 minus 26, times A plus 5 equals 0. Okay, so if you multiply everything together, you get 5a squared minus 26a plus 5 equals 0. And what do you get? You actually get a quadratic equation, where you can just factorize it. You can use your use a calculator to help you. You can use mode, depending on the calculator lah. If you're using Casio, it's mode 33. 5 negative 26 5. Alright, so you can factorize it to be 5a minus 1 or 8 minus 5. Alright, so from there, a is equals to 1/5 or a is equals to 5. Alright, so remember, our job does not end here. Okay, because you're actually finding the value for x. You're not finding the value of a. A is just a substituted values, something that helps you to get your answer. It's like a middleman. Okay, a is like a middleman, right? So what do you do? So when a is equals to 1/5, so 5 to the power x equals to 1/5. Okay, so recall this rule in the indices. If you have 1 over a to the power n, it can be written as a to the power negative n, right? Okay, so 1/5 can be written as 5 to the power negative 1. So from there, x is equals to negative 1, one answer. Okay, what's the second answer? That is when a is equals to 5. So 5 to the power x is equals to 5. 5 means 5 to the power 1. Therefore, x equals to 1. So these are the both answers for the equation. So let's go back to another grade 1 questions. So in this case here, there's no way that you can actually write 6 as base 2, right? And then there's not much substitution that you can do also, right? So if this is the case, then we will have to apply this thing called bringing log to both sides. So basically, there are two types of logs that we have learned so far. One is log base 10, right? So log base 10 is commonly written as just LG, and this is called the common log. It's a common log because you see it in your calculator. So this is called the common log. Okay, where the base is base 10. Then there's another type called the natural log, where the base is base E. So in this case here, log base E is commonly written as ln. So you can find both of this in your calculator, right? So you can use LG or you can use ln because they'll give you the same answer. So I'm going to show you, right? If I'm going to use LG, right? Why do you want to use log? Because actually log is a very, very what do you call it, functional law, because if you were to remember, we have 3 different laws in this chapter on logarithmic functions. We have the quotient law. Okay, I'm going to write it here for you. The quotient law is if you have log m over n, right, you can actually simplify it to be log m minus log n. This is called the quotient, right? And if you have log m times n, this is called the product one. You can simplify it to be this. And if you have log m to the power n, the power n is the power, you can just simply bring it down. Okay, so the purpose of bringing log to both sides is, can you see the power here? Right, x is the power. So if you apply the power law, you can just bring the x to the front. And in this case here, then you can find your x already. X will be just log 6 divided by log 2. And you can just use a calculator. So log 6. But on your calculator, you won't see LG. You will still see LOG. But it's LOG means LG, right? So that will be log 6 divided by log 2. You have to, when you use a calculator, I'm referring to the cashier one. When you press log, make sure you press log bracket 6, then close bracket. Then divide by log, open bracket 2, then close bracket. Otherwise, your calculator will give you error. Okay, so this is using common log. Right, so what happens if you don't want to use common log? You prefer to use natural log. Let's see what happens. Will you still get the same answer? Okay, so we bring the power x down. So x will be ln 6 divided by ln 2. Right, so on your calculator, you can press the fraction first, followed by ln, 6 close bracket, press ln again, 2 close bracket. Yes, you also get 2.58. Okay, you get the same answer. Right, so let's move on to a slightly harder questions. Here you still have to bring ln or lg to both sides, just that the power now gets a bit more complicated. So I'm going to bring lg to both sides. Alright, so this one is my power. So I'm going to bring the power down. Now when you bring the power down, it's very important to bracket it. Okay, why is it you need to bracket it? Let me show you. If you do not bracket it, okay, if you do not bracket it, it will look like this. Okay, then what does this mean to you? This one means 2x. 2x is a standalone term. 2x is a standalone term, then minus 1 times log 4. So 1 times log 4 is log 4. So if you don't put the bracket there, the actual meaning is like this. Is 2x is a standalone, then minus log 4. But if you put the bracket, okay, if you put the bracket, then it's a whole lot it's a whole different things. If you put the bracket there, and if you open up the bracket, what it means is that you will take 2x times log 4, and then negative 1 times log 4. So what you get is actually 2x log 4, then minus log 4, which is what you want, okay, which is the correct answer. So therefore, it is very important, okay, very important that you put the bracket there. The bracket must be there. Okay, right, so let's continue. So likewise, when you bring x plus 2 to the front, bracket it. Okay, there are two ways of doing. Okay, from here, there are two ways of doing. Okay, one way is you open up the brackets. So which means you will have 2x times log 4 minus log 4 equals to x times log 7 minus 2 log 7. Okay, and then you bring all the x terms together. So that means 2x log 4 minus x log 7 equals to 2 log 7 plus log 4. Alright, and here you factorize your x out. You get 2 log 4 minus log 7 equals to 2 log 7 plus log 4. And so x will be equals to 2 log 7 plus log 4 divided by 2 log 4 minus log 7. And if you use a calculator to work that out, it will give you 2 log 7 plus log 4 divided by 2 log 4 minus log 7. You will get 6.38 as the answer. Okay, this is one way of doing it. That means you just put all your x terms together, factorize it out, okay, and then carry out some algebraic manipulations. Another way is you can actually continue from here. So basically, because log 4, you can just use a calculator to evaluate log 4. So log 4 will give you 0.6021. Put it to 4 significant figure. So you will have 0.6021 and times 2x minus 1. And then likewise for log 7, you can just use a calculator to work it out. Make sure you put it to 4 significant because your final answer is 3 significant. So before your final answer, you should always have more significant than your final answer, which is 3 significant. Okay, then the next step, we'll just open up the bracket. So 0.6021 times 2 give you 1.2042x minus 0.6021. You have to write it smaller a bit, otherwise I have no space there. Then plus 0.845 times 2. That will give you 1.69. Oh, there's an x here. Alright, then we put all the x terms together, which is 1.2042x minus away 0.845x, then equals to 1.69 1.69 plus 0.6021. So 1.2042 minus 0.845, that will gives you 0.3592. X 1.69 plus 0.6021 gives you 2.2921. So X will be 2.2921 divided by 0.3592, and that will gives you 2.2921 divided by 0.3592. That will also give you 6.38. Okay, the same answer as what we have done on the left hand side. So it kind of depends on you. Okay, if you're very strong in the algebra, then using the left hand side will be better, right? Because you don't have to deal with so many decimal places. All right, but if you're not so strong, then you have to be very careful, because when you log 4, you see you get 0.6021, a lot of decimal places, so you have to be very careful with that. Right, so now let's look at another type of questions. It's slightly different, right? You're given an exponential equation, then they're asked to evaluate 6 to the power x. Okay, but if you were to recall, right, from the beginning to this questions here, all the while we have been using one or two rules from the indices. The very common one, of course, will be this guy here. We've been using a lot of these. Okay, right. So likewise, we're going to use this rule again. How are we going to use it? We're going to use it to break this guy up. Also break this guy up. And this one we're going to just going to leave it alone. So this one will give you 2 to the power x times 2 to the power of 2 times 3 to the power x times 3 to the power negative 2. Okay, then we're going to do some grouping, meaning you're just going to group similar terms together and then group. Yeah, so what are the similar terms you can group together? For example, this guy here, okay, we can put them together as you just put them side by side. That's what I mean by together. And this one, it's in integer fractions, numbers, so you can put numbers together. Okay, right, so what do we do to base? Basically, this one, anything that is with this number, you can just use your calculator to have you evaluate. Right, if you have so you use a calculator, punch the number to the power of 2, and then times 3 to the power of negative 2. That will gives you 4/9. Then how about this one? This guy here, we can apply another rule. So that's the reason why I say that all the rules of indices, you must have them at the fingertips. Right, one of them will be this guy, a to the power n times b to the power n. Right, now you're having the same power, so what do? You just multiply the base. Same power but different bases, you just combine them, multiply the bases, then to the power n. So here, likewise, it will give us 2 times 3, and then to the power x. Okay, so that will give you 6 to the power x times 4/9 equals to 6 to the power of 2x. Right, so how are we going to continue from here? Now remember, 6 to the power of 2x is the same as 6 to the power x times 6 to the power x. Right. So I can actually remove 6 to the power x on both sides. I can divide it. But then I need to, if you want to divide it, then you will have to include a condition. The condition is that the 6 to the power x cannot be equal to 0. Right, because if it's equal to 0, then you can't divide something by 0, give it undefined. So if you want to apply something like this, right, so you will need this condition. So from there, 6 to the power x will give you 4/9. And then with the added conditions there, that 6 to the power x is not equal to 0. Okay, so this is another type of questions that you may encounter in the exam in the chapter of solving exponential equation. Another possible one would be this, where you ask to simplify. It kind of looks very complicated, but actually it's not. It's not complicated. It looks complicated, but it's not. Because if you were to examine the numbers given to you, all the bases given to you, like 32, 4, 8, 2, 8, right? You can see that you can actually express all this number as base 2. Right, so 32 is 2 to the power of 5. 4 is 2 to the power of 2. And 8 is 2 to the power of 3. Over 2 to the power of 2x times 2 to the power of 3. Okay, so here we have to apply another rules. This one here. So basically, so far, what are the few rules that we have applied? The very common one would be this one here, right? And then we have a to the power of n if you have same power but different base. And then we also used a to the power of negative n is 1 over a to the power n. And then which one? The radical one. Change your radical to the index form. Okay, so I think these 4 rules are rather important. So you just have to make sure you know them well. All right, so here, okay, the common mistake some people make is that you take 5 times x. Okay, you remember your neighbor, but you forgot the one that's further away. So that is a common mistake that some people make. So you must remember your close relative, also relative that is distant relative. Okay, don't just remember close, must also remember distant relative. Then the next one will be 2 to the power of 2x minus 4 times this times this. 3 times x, 3 times 2. Then over times this times this. Okay, so let's simplify further. Right, so here we can add the power. You add them up, that will gives you 2x plus 3x, that gives you 5x. Negative 4 plus 6 will be plus 2. Okay, then simplify this also, add up the power. 2x plus 3x is 5x, then minus 3. Okay, so you will see that you do have a common term here. So if you have managed to come up to these steps, then congratulations, you're very near to getting the final answer. So you will see that you have a common factor, this guy here. So if you have a common factor, what do? We can actually factorize it out, right? But before we factorize it out, maybe we write it, separate them, okay, into 2 terms. Then it's easier for you to do the factorization. Okay, so now I can actually take out my 2 to the power 5x. Okay, right, so when you take out 2 to the power of x, you're left with 2 to the power of 5 minus 2 to the power of 2. Okay, so what do you see? The 2 to the power of 5x and the 2 to the power of x, the denominator and the numerator, they can go off, right? Can divide each other to gives you 1. Then the next important question is that how do I evaluate this left circuit for you? So remember what I said earlier, if there's anything that's involved number, you can just use your calculator to help you solve it. So just use a calculator, punch in 2 to the power of 5 minus 2 to the power of 2 divided by 2 to the power of negative 3. And you will get 224. And that is the answer. So congratulations to you and me that we have survived this crash course on solving exponential functions, and I think you will deserve this certificate of accomplishment. You should give yourself a big clap.